Thank you for joining I Am Possible, which is India's
Thank you, Eddie.
first
Yeah.
future tech meets sustainability podcast. And today I'm delighted and honored to have with me Mr. Deep Bhattacharjee, who is asking some seriously deep questions. His interests and work of research includes theoretical physics, mathematics, and he is the project director at AATWRI Group Aerospace and Defense and currently the founder at India Through Our Eyes. So Deep, it's a complete pleasure to have you on the podcast. Thank you for taking time and being part of the show. Now, I've been following you on LinkedIn since over a year, and you are, I think, amongst the 5 individuals I have in my connection who is pushing the boundaries of what is possible and asking really deep questions. And these deep questions that you're asking are not limited to a specific subject. The reason I am in awe of what you're doing is because you seem to have a grasp of physics, mathematics, life in general, of philosophy, aliens, and the list always seems to be kind of endless because every post of yours is insightful, and I get very excited reading your posts. So to all my listeners, if you are not following Deep Bhattacharjee on LinkedIn, you should, because it's almost like a learning in itself if you are a curious individual and who's asking for deep questions. So Deep, let's start with your journey. Who are you?
Yeah.
What you do? And why do you do what you do?
Yeah. Actually, it all started quite an accident. In sort of accident, it started I completed my graduation, and I was totally. I was totally into the fact that I will do some government jobs, and then I will move forward with that. But suddenly things changed. Then I started reading, and after going through deep into the aspects of the nature, I kind of feel that there is something which is deeply, which is so deep that still humans didn't get a grasp into this, because there are two things why humans didn't get grasp into this. I came across all the possibilities why there are these things which remain unanswered, why there are these mysteries, why there are such variants, why there is invariance, why there are differences in symmetries in unification schemes. Then after a long years of study, around 6, 7, 8 years of intense study of books, research papers, different sorts of patents, I realized that the nature itself is very stringent. Like, you can explore nature if you are going through from a narrower from a, what can I say, from in between the macro and micro level. If you are there in between exploring the nature will reveal herself to you completely. But now, if you're trying to push the limits, the farthest, if you try to explore the nature at the very biggest scale, the scale which is 1,000 million times greater than the sun's, the solar masses, or the scale which is so tiny, like, say, you can say the Planck scale, where the notion of space-time itself breaks down, and where the energy limit is so high that we humans doesn't have that us we humans doesn't have that much of technology to accelerate particles to that energy scale. Strange things are happening. Like, you will see that some dimensional freedoms are there. Like, there are strange, like 11 dimensions, 12 dimensions are there. You just can't imagine what are there. Like, all sorts of things are there. Then I find that this is quite interesting, that why can't we get a grasp of these dimensions? Then I thought that no, it's not possible, because in the deep down heart of the physics, there are some things which we are not approaching the right way. Like the traditional, no, I am not such a big scholar or scientist. I'm nothing like that to say, to make this statement. But what I think, what I feel is that there are some things like if you could go back in time and see around the development of the alternating current, the development from the discoveries the Tesla around his experiment in Colorado Springs laboratory around say 1890 1894, you will see that he has done something remarkable, but he is not completely sure what he is doing. So he didn't make a statement about that. Later, around 1930 to 1940, some classified researchers started to work secretly and developing those ideas, which have been so censored by the Western governments that their applications are limited to, what can I say, that applications are limited to some sort of highly defense oriented or aerospace structures, and that too with a very limited exposure. Like we are not getting to know about them, but the technology is there. The different academia is so obsessed with the what can I say, that they are so obsessed with the pillars. Like, you know that when Einstein developed the theory of relativity, so he completely shattered the notion of absoluteness of Newton's, where Newton's dominance were there for almost 200 years. So what Einstein say that no, the concept should be relative. It should be something elastic, something plastic, which can contract, which can retract, which can dilate. So nothing is there. Everything, nothing is there as a static, as a solid. Everything depends on the perspectives of how we are observing our relative motions. So depending on the frame of reference, then I remember that a German book has been published whose English translation is 100 Scientists Against Einstein. 100 scientists or 100 authors against Einstein. It was the English name, but the book was in German. So German, and so at that time Einstein was, I mean, kind of like, what can I say, that nobody was accepting. Even I have seen that there are universities, I will not name the universities, who have rejected Einstein's special theory of relativity paper, saying that it's kind of a sci-fi, science fiction, like it's kind of a science fiction. Einstein started a sort of a revolution in physics. Like he said that no, as Newton described, that this world is a stage where we humans are playing game, and time is just a one-way entity moving forward and forward. We are so bounded by this notion of time. And then suddenly Einstein said, no, this is not the fact. We can do much more things with the time. We can do many interesting things. And then he developed with his colleague Nathan Rosen the more modified metrics of, what can I say, the Einstein-Rosen wormhole, which took our level of imagination to a very high level. Like we can travel through time. Then the Alice's drain hole Homer Alice prepared. Then Keithron developed further, and then Stephen Hawking then argued back, like said that no, there are chronologies, there are chronology protection mechanisms. We just can't go through time because it is restricted to our scale. So it is restricted. It is available on through a Planck scale or limit scale. Then Thron, the Nobel laureate, he argued that no, Hawking was perhaps right, but maybe if we think that the energy, what Hawking said, that if the stress energy momentum tensor should be negative to maintain the, what can I say, to maintain the suitable tension to traveling through time. So it can develop the null energy conditions. So there are different energy conditions, like, so we can say strong energy conditions, weak energy conditions, dominant energy conditions. Then the paper published by Thron said that no, it's not at all that Hawking is wrong, and I'm not also saying that Hawking is completely right, but what I'm saying is that there can be the energy violations, but it can be there in small patches, like it is not there in the whole structure. So some structures are there which got the freedom from which you can travel to time, and if you see that further modifications had been made through the Rai-Choudhury equations, and the most important thing which I've observed is that in the modified dynamics of relativity, if you will see that Keithron and his friend Morris, they have developed an elaborate paper with with complete traversable wormhole solutions, but they mentioned that no, it is not possible for us to travel through time, and also travel through space-time, because we need some sort of exotic matter. So what is the exotic matter? See, right now, if we ask that, yeah, there is a chunk of marble there and its weight is minus 2 kg. So it's kind of absurd, no? Nothing can weight minus 2 kg. It should be at least some increment from plus 0. From 0, some increment from 0. So it can't be minus 2 kg. But if it weight minus 2 kg, then this will satisfy the Einstein solutions in such a beautiful way that everything will be possible. Everything will open up. The tension will open up. The tension force will be flexible and suitable enough for the wormhole to not get collapsed through the journey. So they're developed from the Rayleigh equation and from the another dynamics of gravity called if-RT theory is good. I have written a paper on Swanmori's wormhole, and there many authors have argued that if we can develop the stress energy momentum tensor, the effective stress energy momentum tensor, which is quite a rigorous and complicated, then perhaps we should develop something like we can ignore that energy effects and we can, with the positive energy, we can travel through wormhole. So that's the thing. Look, that's the thing. Because Michio in an interview said that time travel, the concept, the problem of time travel is actually solved by physicists and is now actually an engineering problem. So what I have seen is that if you see carefully that the Kepler Space Telescope, I mean, it has discovered a lot of exoplanets, right? The extrasolar planets. And like you will see that the TRAPPIST, the T-Gardens, there are different planets. And those planets, they are mainly discovered by what mechanism? The radial velocity, microlensing, or you can say transit photometry is the most dominant thing to observe those planets. And this is a technique which has been used by NASA. So you will see that there's planets where the even say the metallicity, the planets are standing in a Goldilocks zone. By Goldilocks zone, I mean that the zone which is at such a suitable distance from the star that water is not boiling and water is not freezing. So it kind of, in a level temperature, the planet has atmosphere, it has methane, carbon, which is very much necessary for the life. So, and ammonia is there. So there can be life forms. The problem is that, so, I mean, it's so the million years away. So if you developed a rocket, say you have developed a rocket with a tremendous power, a superhuman rocket which humans also. Now what our current technology says, that our Tchaikovsky was a Russian school teacher. They gave some sort of notion that by developing Newton's equation, he said that if a rocket has to reach space, then it has to shed up its limits, like the stage separation occurs. Stages are getting separated while the rocket is trying to reach the upper atmosphere of the carbon limit. Now, the main constant is that if you will see that we are not even close, we are not even any small close to reach the approximate level of the light speed, like 3 lakh kilometers per second. Like we can't receive, I don't know, we have even achieved 1%, 2%, 3% of that. And the second constant is that we are relying on fuels. So how can you think, there are things that a rocket, the 80%, 90% of the rockets fuselage is fuels, right? I mean, there are liquid propellants, there are solid boosters, so the fuel gets burned up within some minutes. So how can I think that the fuel will stay for such a long million years of time? Okay, even if we argue that the fuel is staying for the long million years of time, maybe there's a large rocket with a large fuels are there. Now, time. So what Einstein said that we can't approach the speed of the light. So we are thinking that, okay, say we are going through 1 lakh kilometer less per second, we are going to 2 lakh kilometer per second. Now what will happen is that even if we are going to 2 lakh kilometer per second, we need some millions years to reach there. So how the humans can survive inside the rocket? Say humans can survive and the rocket has fuels to go there. Now, if we are traveling through that speed, you will see that there is a notion which Einstein said is happiest thought, that there is a relation, equivalence principle between gravity and acceleration. So as the rocket is approaching at such high speeds, its acceleration is increasing, this results in increment of gravity. So anything inside that will be crushed. So the humans will be completely crushed. So that's why if you see a NASA scientist, Miguel Alcubierre, he developed some sort of a metric, some sort of mathematics. He said that, look, why don't we just go through a wrap drive? So what exactly is a wrap drive? The wrap drive is a technology phenomena which says that, suppose there is a point like X in the X here, and there is a point like Y here. We are moving from X to Y. So what we are doing, we are just propelling from X to Y. But remember that there is an escalator. There is an escalator which is starting from X and ending at Y. And the rocket is standing at the escalator. So what is happening? The escalator is moving. The rocket is not moving, right? So the space between the rocket and the X is increasing, and the space at the front of the rocket between the end point Y and the rocket is decreasing. So the space is expanding at the rear and the space is contracting at the front. So this is the reason that if we get ourselves embedded in a wrap bubble, some sort of thing, then we can move through space, and that with a high speed. Now, if you see closely, all those papers which have cited Alcubierre's work, they have argued some strange things like, yeah, we can eliminate the force of gravity if there's a toroidal field. Like you will see that what is a toroid is generally something which has two type of radius. Like what is the surface area of the torus? It's actually 2 pi small radius into 2 pi large radius. So if we take a modified form of torus, like a horn torus, you will see that the small radius and the large radius, they're approximately equal. So if we made some kind of modifications, then we can somehow eliminate the tidal forces and we can go. But the fact is that the energy that we need is like, it's like the whole energy of the universe if you say we need that. So it's not possible, right? So now the rocket is quite, giving a hindrance to our interstellar travel. The Alcubierre wrap drive is giving a hindrance to our interstellar travel. What we can do? Now the best possible thing is, why not we try to implement and incorporate those technologies of the Russian scientist Eugene Podkletov, Searle, Tesla, some work, Thomas Townsend Brown's of work, where they develop some sort of notions like to absorb energy from the nature, to develop a gradient, to develop anti-gravity. Look, we know that gravity is monopole, it has no poles, right? You know that other charges have poles, like electromagnetism has north pole, south pole, positive or negative pole, gravity has no pole. But why not develop a notion like we are developing a geometrical structure? And there are certain things which I'm not going to see because it's so technical, but we are developing some vehicles with a geometrical structure. You will see that this is a specific thing which the aliens or the other, just flying objects which are unidentified, they are relying on. That is, they are absorbing the energy from the nature. They are not dependent on any internal energies of the fuels. So that's why you will see that their shape are no longer cylindrical. Their shape is circular and with a large surface area. And that large surface area is because of the geometry, the ionic flow. And this will lead something like that. If the flow, it starts from the top and converges to the bottom, there are certain things, certain theories. I have papers on that, but I couldn't publish it in journals because everybody thought that, no, this is not accepted. So orthodox, the societies, they will say that, no, just like that whenever someone tries to develop something new, the society, the scientific community opposes their view. What they are relying on is that they are relying on something like that. They are developing a sort of attractive gravity shield over their spacecraft and a repulsive gravity shield below their spacecraft. So the attractive gravity shield is attracting them from the top, and the repulsive gravity shield is repulsing them from the bottom. So they're moving upwards. And if you closely inspect all the sightings which have been taken place over the water, some sightings have been taken place over the oceans, you will see that the water level rises whenever the craft is going above them. So why the water level is rising? Because the repulsive gravity field is getting developed under the craft, and that is why it is taking the water up repulsive gravity. So
Right.
these are the things. These are the knowledge. Tesla said, even Tesla said that we have to develop energy from the nature. Nature is a tremendous source of energy. Like, you can see the Casimir vacuum, right? The Casimir vacuum, nature is such a great source of energy, but we know, but we haven't done experiments how to harness energy. We are relying on some these sort of fuels.
You have touched so many interesting things, and I think I would like to stress that you mentioned that you have done studies but not like really the brick and mortar, the traditional education system. After your graduation, you have looked to educate yourself with education content which is available online rather than your traditional brick and mortar school. So kudos to you, because you have done something which is exceptional, because your mind is like it's full of beautiful insights and foresights. If we take up piece by piece, I think we'll be able to, plug in the loopholes that we have currently in our system. You mentioned that in the beginning, that the problem with science and technology is that they are stuck between somewhere the macro and the micro. And I think that there is a need to possibly maybe find something in the middle, but also possibly go right deep down, completely to the micro. Because you mentioned the Planck scale. We need to kind of figure out exactly what is nature, the source code of life. And there is a possibility for us to go deep below. But I think what stops us is, I think, the traditional academia and business, because we feel that what is the use of creating technology which does not have a business marriage? So we are continuously going towards not finding researchers who are so deeply vested that and so into the future, that if you let them loose, like people such as yourself, we will be able to accelerate in the future that we've all been waiting for. You also mentioned, you spoke about time travel, you spoke about wormhole, you spoke about leveraging nature, anti-gravity, what Russian scientists are doing, space travel. You touched upon alien spacecraft, and yes, there is a certain section of people who actually do not believe in aliens. But yes, I've been someone who's been extremely fascinated by aliens and their sightings from a very, very early days. So maybe it would be cool if, I mean, you spoke for quite some time. Can you summarize, I mean, like a quick summary, if somebody was to say, okay, give me a brief on what could be the ideal way for us to be intergalactic beings, the technology that we might use to become intergalactic beings?
Why not we take the concept of bread slice concept of time, like past, present, and future, they're all happening simultaneously at the same time. But why not we are observing it? Because from past to present, there is a huge gap. Present to future, there's a huge gap of time. Now, what is controlling this time? See, if we think time as a dimension, one dimension, then we will be bound to think that it's an arrow, because a straight line is only one dimension. It is moving in only one word. I mean, it's moving only in one direction. So, if we somehow think that time is the two dimensions, like it is a circle, it's a circle kind of thing, then we will see that somehow we are there at one point of the circle where we are observing only the lines of the arc of one circle. That is, we are observing locally, and that is, we are perceiving it somehow is a one-way arrow. But from the whole perspective, the time is a two-dimensional circle. So everything is going, but it is just a huge gap. How can you harness this gap? So by exploiting this physics, we can see that supersymmetry is such a powerful concept of symmetry, which somehow solves most of the cosmological constant problems. But those are not discovered because of the energy constraints, because a particle has to accelerate at such a high momentum and kinetic energy. We are not having that much of a space. So I am not sure, but I have read somewhere, I am not, I can't remember the source, is that if we can make a tunnel from about a distance from Earth to Sun, I may be wrong, but it's an analogy, like it should be that long from Earth to Sun, and if we can accelerate the particles, like say, what is the distance from Earth to Sun? 8.40 light minutes, something like that. So if we can distance that, if we can make a tunnel that long, and if we can accelerate the particles, and by going through such a long distance, going, it will develop some form of kinetic energy and the momentum, and then when they collide, then the collide will be so strong that they will eventually split up. Like you can say that what are the fundamental particles? The fundamental particles are, there are two particles like fermions, which are the matter building blocks, and bosons is the energy. Now, if you go through bosons, inside bosons, then there will be strings. And if you go inside fermions, there will be quarks. And if you go inside quarks, there will be strings. Strings are the fundamental particles. And there are two kinds of strings: so open string, closed string. A gravity is a closed string, and a photon is open string. So if you see that it is very difficult to detect graviton, but it is somehow easy to detect photon, because we can see photon, but we can't see the graviton. Why? Because this gives a hint that string theory is going the right way. Why? Because people are, because many people are saying the string theory is a garbage. It's a mathematical garbage. It's rubbish. No, it's a so complex mathematics. It has some sort of weird mathematics, topology, unitary geometry. I mean, that's a, you will see that why are we not getting so much? Why are we not able to detect gravitons? Because you know that they're closed, they're rubber band closed strings, but photons are the open strings. So as an open string, photons are restricted to some boundary walls, and they're oscillating within that walls. But graviton being a closed string, as soon as it is produced, it has no such boundary attachments. So you can easily escape to higher dimensions. So why are you not able to perceive them? Because as soon as its creation it leaks to higher dimensions. And another, that's why that this gives a hint that there are dimensions. There are dimensions beyond our notion. And what Roger Penrose said, the Nobel laureate Roger Penrose said, that we are in a cyclic cosmology, like history. Big Bang, Hawking said the Big Bang is something beginning. Penrose said the Big Bang is not the beginning. So if you see the equinotic cosmological model, you will see that, yeah, there are some things, but anyway, the FRW metric, they are creating some defined things. Another thing I would like to mention, that why people are not digesting string theory. If you see that, you have probably heard of the term renormalization, or the divergences that is arising when we are trying to amalgamate general relativity into quantum mechanics. Because you know, general relativity is something which is very big, and quantum mechanics is something which is very small. So there's a scale mismatch between the two. So when we are trying to make a cocktail out of the two, general relativity is saying I am too big for the quantum mechanics to get into. Quantum mechanics saying I am too small for to get into general relativity. So maybe there are some notions of increment of dimensions to mix them. Okay. So there arises a problem, which is a divergence. Like if you see the Einstein-Hilbert action from the loop to momentum scale, you will see that there are certain things in the quantum gravity which will say that there are some sort of the Riemann, we get some quadratic logarithmic divergences, unwanted things. You have to renormalize them, to cut them out. So what are the things that we need to do this? So first of all, there are things like, if you see, I think you have heard of the famous quantum physicist Werner Heisenberg, right? Heisenberg has given a theorem which is called the uncertainty principle. If you go into the deep mathematics of the uncertainty principle, you will see that what Heisenberg said is that there is something which doesn't commutes. So if you suppose you are traveling through a road, now I would like to observe your position, but as you are traveling, I would not get your position, rather I would notice your distance. Now you are standing, and now I would like to get your position, but you are standing, so I will get your distance, not your position. Same thing is true for energy and time, and some other relations are there. So this is that when there are particles, it is such a small zeroth dimension. So obviously, their energy will be very high. But if we do some sort of reciprocals, Like if we extend the particles to strings, then the energy will become low. So this is the beauty. These are different things that I've explored. Like, yeah, these are things. And to make one thing that the interstellar travel, I should say that no, it's difficult because one can't go inside the singularity, inside the black hole, and one can't see the strings, which are like 10 to the power minus 35 meters or something like that. It's impossible. The notion of space-time breakdown is beyond that, and the loop to quantum gravity plays role. So what I think is that it is obviously not possible for the humans, because as you probe deeper into nature, nature restricts you because she doesn't want to reveal her freedoms, doesn't secret. Because you know that if we develop knowledge about everything, then nature will say that, why am I still there? Humans have known everything. No. We should keep something in ourselves a secret. We won't reveal the humans. But what humans are doing, they are trying to perceive it mathematically. But there are solutions in which humans should perceive it experimentally, but they're not getting into that. These insights we need to develop to make intergalactic things. We can't rely on the conventional physics. We have to break the barriers of relativity, of thermodynamics, of Newton's laws. Then only we can make that, we can achieve that level of freedom. Then only we can achieve that level of freedom by which we can incorporate some things which are beyond the normal notion of humans, which is a sci-fi.
Right.
There are things in physics.
Let me just break down whatever you mentioned, because it could get very heavy on people, you know. So you spoke about the Hadron Collider, and you said that maybe if we kind of hypothetically build a large Hadron Collider, and there are some people who are talking about possibly building a Hadron Collider on the moon. So I have not heard the theory about building creating a hole till the sun, but through maybe building a large enough Hadron Collider, maybe through a hole till the sun or around on the moon, maybe we'll be able to understand ourselves better, because so far we do know what are we made out of. We fundamentally made out of atoms, but we are not able to go deeper and completely understand. Gravity is something which we are not able to understand. In string theory, which is trying to kind of find unity and unify, you know, the macro world to the micro world, is unable to do it. And there is, everyone is saying that string theory is pretty much a waste of time. But I guess some of the smartest minds in this world are vested in have vested the entire life in this, because I think understanding quantum physics and quantum mechanics through whatever the string theory and is the reason we've got so much of fantastic technology. So there's no way we can undermine that. So yes, I mean, you also mentioned that nature is kind of restricting you, because yes, you know, when we go really deep, and if and when we completely understand the bottom of everything, what are we made of, then what would be the difference between humans and gods? Because we would be gods, because then we would be building these spacecrafts which will allow us to travel, you know, intergalactic. It would allow us superhuman powers, and then in maybe some ways it would allow us to kind of breach the fundamental law of physics and do something which is like build our own virtual world. For example, there's this individual called John Sweet. He's got something called hypothesis called Transcension hypothesis. So what he says, that the entire human race is trying to travel outwards, you know, go to Mars or find a space in the a planet in the universe, you know, where we could be sustainable. Because I think 5 or 7 mass extinctions happened, and we are possibly very close to another mass extinction level. So we are trying to go to Mars, another planet, and find another home for us. But John Sweet has a complete different approach, which he calls a transcension hypothesis. So he says that instead of going outward, why can't we go inward into the matter, into the atom? Because that's what in fact virtual reality is doing. That's what the metaverse is in some sorts, because that is when we can create virtual worlds so believable, and possibly maybe in the future where we'll be able to kind of you know, map the structural and functional capabilities of every individual's on universe and upload it onto a computer, so it goes back into the atom. So maybe that could be one way. So since you breached the subject of string theory, let's stay on string theory for a little while, because there's one camp which believes that string theory will give us all the answers, and there's others, which is a large number of people, saying it's a waste of time. Then there are some fantastic physicists. There's Stephen Wolfram, there's Eric Weinstein, to just name a few. There's others also working on a unification theory. What are your views on that? How far away you think are we from understanding that theory which will define who we are and the universe?
Look, I will say that there is a scale of civilization by a famous physicist called Kardashev scale. So what Kardashev state is that there are some scales of civilizations, like there's scale 1, scale 2, scale 3, and through each progression from 1 scale to 2 scale, you perhaps heard of Dyson sphere, right? That hypothetical thing which, I think that right now, we are not so much advanced, because look, the second Kardashev scale right now makes our standing in 0.73, which is our current limit. We are not even close to 1. So there are 2 and 3. Even Michio Kaku has developed it, and many physicists developed it further, like 4 or 5. So what I can say is that, look, right now we don't have that much of technology, because you know that there are two kinds of thinking. It's like, if we approach a problem, then you will approach it in a straight way. And after you died, some 100 years or 200 years later, someone will see, no, we can't approach it in a straight way. Let's approach it in a round way. That will perhaps be the shortcut. So we are now thinking that, we have to make something like nature is so strict, we can't go deep inside strings, we can't develop so much big tunnels, we can't achieve so much energy, we can't develop exotic matter. So maybe at some later time, some brilliant minds will come up with some things which will alternatify the facts. Like there come up with some shortcuts, some strange things, like in which it can be achieved in a different thinking, different perspective, different experiments which we are not aware of. We are seeing it, but we are not getting like what this is, the implementations of this. So as you know, there is a famous conjecture in computer science called P versus NP conjecture, which is a Millennium Prize problem, unsolved problem.
Yeah.
If you see that, so you know that if we can make calculations exponential or something, there are developments. We are not yet. We are not yet close to that thing, right? We can't make a calculation which is incrementing in an exponential rate. So perhaps our computers will develop, our artificial intelligence will develop, and as Nick Bostrom said, that maybe we would hit some kind of a singularity, like there will be some sort of intelligent explosions. So there is another danger, right? Because if you think closely, you will see that we have developed from the chimpanzees, right? Now we have caged them in the zoo. So why not the machines that we are developing in the future, they will cage us and they will dominate us. So I am not getting into the point, but I am saying that at that limit, when the machines will be able to dream, they will be able to develop their own programming. They will be that much advanced. Maybe at that time we will get some insights. So these are the things. So maybe in future, look,
are you saying that we will understand string theory? Humans won't be able to understand it, but the artificial general intelligence that we develop will be able to find these deeper questions that we need to know. But by that point in time, we just might have machines that are so intelligent that then we will become the ants, and we won't be relevant. So even is that what you're saying, that they are you saying that we humans might just not possible get the answers of the that unification of a theory, and it could be machines? Is that what you are getting at?
Perhaps we humans can do this, but at a much later time. If you see when the Wright brothers discovered the airplanes, right? That Wright brothers in 1904, so now it's what? They have discovered the plane in 1904, and now it's 2022, and now we are developing rockets. We are developing what can I say? The scramjet engines, the air breathing engines, the wave rider, which are basically running on shock waves. I mean, so you see that there's a transition like from 1904 to 2022. I mean, there's a immense breakthrough in the aerospace and the rocket science. And I remember that I have seen a magazine, a New York magazine, something like that, which stated that humans were never able to reach beyond the atmosphere of Earth. So can you imagine that right now, reaching 100 kilometers, the Karman's limit, it's a child's play. So there are breakthroughs. The Wright brothers plane flew about some, I think, the 2 to 3 feet from the ground in 30 to 40 seconds. I don't remember actually. But now we are just going through moon. So why not wait for another 100 years? Maybe we should die, but our future generations, they will develop. So it is going and going. Research is going. Maybe, look, everything has an end, right? Everything will hit a singularity. Everything has an end. So maybe that end is devastating. Maybe we are not thinking about that scenario. We will hitting the singularity. But maybe before that, somehow we have reached a notion, like maybe to solve all this. And as I mentioned, mass extinction, I will say that there is a famous book called Dark Matter and the Dinosaurs by one of the string theorists called Risa Randall, because she, along with another scientist, Sundram, they have developed Randall Sundram models. So, models, and there is an analogy. We are not sure, but the analogy states that the theory states that why dinosaurs got extinct, because the theory states that their hypothesis, like comets or meteor showers, asteroid showers, or something like that, which hit the Earth, and that makes them extinct. So, if you see closely that our sun is moving the Sagittarius supermassive black hole, and around 200 million years, which is in the cosmic year. And the motion of the sun is not at all like this. The Earth is moving at a helical around the sun, and sun is moving at a sinusoidal pattern. So there are certain, after some million years gap, there will be a portion in the galaxy from where the sun will be passing, and at that portion there will be high concentration of dark matter, chunks of dark matters. So at that time, maybe those gravity attractions, they will just invite the comets, meteors to Earth, and maybe this will get another mass extinction. So Hawking perhaps said it right, that yeah, we have to look to the stars, we have to go beyond the Earth, we have to find something. The Interstellar movie is there, which is a beautiful movie. Like, it is the first movie to showcase a wormhole with the science. Like, it is developed by that scientist, Kip Thorne, right? Who have first developed the Thorne-Morris wormhole solutions in a paper. I don't know, but there's some interesting things that there, and it will happen. But maybe we are not going to achieve it. But somehow, look, you can see that if you take Apple, see, let me give you an analogy. If you take Apple, and if you try to move from one point of the apple to another point of the apple, what will you do? Our traditional thinking was that we can do that. Why? By going through a geodesic path from this to this. Then we have developed notions like, no, why don't you dig a hole and go from here to there? This is a shortcut. This is a wormhole. This is an alternative analogy of the traveling. So why not in the future tense, some scientists will develop an alternative analogy of these things, which we are not aware of, but which are there in front of our eyes, they are floating in front of our eyes, but we are not aware of. Look, before string theory, supersymmetry needs to be developed. Because without supersymmetry, string can't develop, because it's a bosonic string theory is there, and after that, the M theory, you will see that there are certain branches of M theory, like type 1, type 2A, type 2B, heterotic S32, heterotic S800, and also the 11 dimensional supergravity is there, which is given by Edward Witten. They're all interrelated by topological and strong duality. I mean, some weird monstrous mathematics are there. So, see that if supersymmetry developed, then we will somehow get a notion like you know that nothing in this universe exists as a single. They are always exist in pairs. So the analogy is that if there exists photon, there might be a photino. Photon is a boson, photon is a fermion. If there exists electron, it's a fermion. There might be a selectron somehow. If there exists electron, is a boson. Electron is a fermion. If there exists a Higgs, there might be a Higgsino. If there exists, what can I say? The quarks, there might be S quarks. We have developed. We know that Dirac has given his whole analogy, the Dirac hole, and he predicted the positron. The positron is there, and with the help of the fine structure constant and the Feynman's rule, like 137, the electron positron, they kind of annihilates into gamma ray and energy is equal to mc squared. But if supersymmetry develops, then we will get a notion like, that in this universe some cancellations are happening to symmetry. Always some cancellations is there, because nothing can develop, accumulate, because this will lead to a catastrophe. So there must be some sort of cancellations going on, is increasing, and then cancellation going on, and this sort of thing. So this cancellation parameter is the supersymmetry. If it is developed, then we'll get a notion, there are strings ahead, we need to loop, and we might find the strings. And then, before that, what I like to suggest is that, why not we explore those sensor takes? No, I'm not getting into strings, but I'm getting into this developed interstellar intergalactic things. Why not we take those things into account and try to incorporate with the current rocket science phenomena? Maybe we can develop some sort of thing, because they have said they have achieved some sort of unification. It sounds weird. I know it sounds weird, because what can I say? If now I said someone that, there are unifications of gravity and electrons, shut up. No, because if we comb our hair and we develop a small piece of paper in the ground, and if we put the comb, the paper will get attracted to the comb, right?
Right.
Some sort of, think such small electrostatic charges in our hair is greater than the whole gravitational pull of the earth, and it is attracting that paper from the earth. So can you think that how much weak gravity is? It's like 10 to the power 20 or some magnitudes weaker than the weak nuclear force, weakest force of the nature. So somehow they have developed with sort of geometry and anti-gravity phenomenology, which is known as electrohydrodynamics. You won't get this into any books or like this. You will get this to classified technologies, letters, patents. And they have developed some sort of unification scheme with those of the electromagnetism and gravity. And they somehow developed the anti-gravity. So that maybe there are certain things which are floating around, but we are not getting into either.
I am someone who is a college dropout. I dropped out of 12th, and my education has largely been extremely self learning. I was a musician, but then from 2015 I spent my life educating myself on the internet, because I think the internet is a teacher almost, because and it's filled of education and educational learning content. If you have the desire and intent, you can learn everything. So I mean, please forgive me if for taking this attempt at explaining what string theory is. So string theory is basically these some of the top astrophysicists, physicists around the world who are trying to understand the fundamental code of the universe. What are we made out of? That there's this four fundamental forces of nature: gravitational force, electromagnetic force, the strong and weak nuclear force, and we build out of matter, which is atoms, protons, neutrons, neutrinos, quarks, muons, and deep down these particles have a string which oscillates, and the way it kind makes it a specific particle. For example, if it's oscillating in a certain way, then it's an electron. If it's oscillating in a certain way, then it gives its property of gravity, it's a graviton. And if it's oscillating in a certain way, then it's a photon, and so on and so forth. So what the string theory is trying to do is unite the four fundamental forces of nature with the particles, and once we understand that, I think we will know who we are, what are we, what is the universe made of, and stuff like that. So excuse me if my explanation of string theory was a little vague, but this is according to me what the string theory is. There is so much that we need to know, and we need to ask deeper questions, and I think the problem with the world is we feel embarrassed to ask questions because we feel like, oh, what if we look stupid? But who gives a damn? It's only when you ask these stupid questions you will get answers. Otherwise you will never know the answers, because you will always feel embarrassed to ask these questions. So I, being a college dropout, I have forced myself to be stupid and ask stupid questions, because I guess then you accumulate knowledge, and the more knowledge you accumulate, I think that's the way to create opportunities and businesses. So you know what, from here, I think, because we spoke about so many awesome things, you mentioned about classified and censored technology. So there is a lot going on in the world where just a handful of people know about it. How these alien aircraft comes, how these alien aircraft flies, it hovers, it can break the speed of light, and besides the alien aircraft, there's so many other things. There's the Philadelphia experiment, which hardly anybody knew about. Then there's this Tesla who was working on free energy, but then nobody knows about that. So would you like to, breach that? What are these classified and censored technologies? Why is it hidden? Let's spend some time on this research, because if we get one of these technologies, we truly will be a phenomenal country or a world.
Look, if you see about the Tesla coil, Tesla resonance amplifiers, all sort of things, it is true that when Tesla was experimenting, he somehow got a frost in his chest. He didn't realize it was a beam of some sort of gravity. But that time he accidentally discovered that sort of things, which came accidentally to Thomas Townsend Mount experiment around many 30 to 40 years later. So yeah, Tesla coil somehow predicted some sort of some wireless electricity. So it's not a problem. Different worlds have different scientists are working on Tesla's technology, although many have been censored, classified, not been released by the federal or the government or anything. So those which are there. So Tesla coils have been developed. If you see YouTube, huge coils with billions of volts, there. That's the thing. Now coming back to the Philadelphia effect, what I have to say that if you study deeply, then there are certain phenomena like happening. Look, most people will say that Philadelphia experiment is wax. It didn't happen. But if you see that there are eminent scientists for interpreting Philadelphia experiment, when different authors have approached them, they said that no, we are not engaged in the experiment. But several interesting things have happened in Philadelphia experiment. One is optical blackout. One is electrostatic invisibility. One is Hutchison effect. So this is a Hutchison effect was a true anathema, the curse of this experiment, because if you see the images, you will see that people are getting quite embedded in the walls. Yeah. So everyone died. But this somehow gives us a knowledge, like we can somehow jump into the hyperspace. But it's a catastrophic effect because of the Hutchison phenomenology. But we have developed some sort of, but many say no, it was just a blackout from our eye. It was just a blackout. And another thing, if you see, Otis Sar was a student of Tesla. He somehow said that Tesla somehow developed a sort of teleportation like of thing, but either he is not saying the truth, or he is saying to publicize himself. We don't know that. But
Yeah, because
the PCR,
there is news that the ship, which was at a certain location, kind of just teleported itself and went to and for a few seconds or minutes, then it was seen somewhere else. Yeah. So yes, please keep on. Yeah.
yeah. So now, if we ignore that part, if we ignore that Philadelphia, and if we come to the tradition, the physics, relativistic physics, you will see that it is not possible for a lower dimensional object to go into the higher dimension unless some things are not breached. Why? Because the higher dimensions have higher degrees of freedom, but in the lower dimensions you will not get so much degrees of freedom. See, suppose you are restricted on a paper. So what are your movements? You will go so like left, right, front, back. You will not able to move up or down because you are in a paper. How can you move up or down? Because your whole world is restricted on the paper. Now you will extend the paper to a cube. Now you can move up or down sideward in the cube. Now you made further orthogonal extension to tesseract hypercube, another orthogonal tesseract extension. Ultimately, if you see those 9-dimensional, 10-dimensional hypercube, you will see that there's some sort of a hull, like they are looking like a sphere. So what is the topological connections with this? Why they are looking like a sphere? Because of the fact that if you see close, you will see that if you piece a chunk of mud from the ground, and what is the easiest shape that you can make? A sphere, right? You can't make a pyramid, a square, a rectangle. It will be difficult, but it's why. And every astrophysical objects are spherical, except I am not saying the asteroid, but sphere. Why? Because the sphere is a certain topological thing. It's more, logical to say a ball, because in sphere topology we sometimes have the notion like it is a hollow, but a ball is something which is solid. So why there's a ball or this or the sphere to say? So a sphere is such an object which within a small surface area can accumulate a large volume of matter. So nature, it is a habit of nature to do large things wasting least energy. No. So nature, it is a habit of nature. So that is why the more the degrees of freedom are increasing, you will see that the concept of the cubes, they are getting vanished, and you will see something like that of something like circular analogy with the hull convex notion is down. So these are the things like the increment of dimensions will develop the more degrees of freedoms to move on. You can go any side, even if you see there are some certain higher dimensional objects, you can even perform yourself to attain the middle of that object without penetrating its surface. Why? Because the freedom will increase. But right now, if we are standing on a sphere, we can't get into the middle at the radius without digging a hole. But if the freedoms are increasing, then we can go into the middle without digging a hole. That this is a freedom or more. So in traditional physics, it is not at all possible for us to jump into higher dimensional space, except with some exotic stuffs like wormhole faster than the speed of the light, or something alcubator, something exotic stuffs. But if we approach that thing, I am not sure whether it is viable or experimentally probable or not, because that time when they have done it, they don't have that much of interpretation of phenomenology as of today's technology. They're not aware of phenomenology. But if we take those things and accumulate it and try to mix them up and try to develop something, there can be look, everything is a probability, right? If you coin a toss, then there will be a 50 probability. So why not give a chance? It might be that we can get some sort of notions, and if we develop some notions, if we take into account of that Philadelphia experiment, which is a catastrophic consequence, all the few of the ships have died. So why not we try to develop such technologies with a phenomenology, you improve phenomenology such that the crew will not get died. Because in the first attempts, we have seen that many experimental aircraft they have damaged, they have burst, rockets have burst, the Sputniks or something like that, they have gone into fire, killing the crew. So from that, humans have developed a sort of intuition, like I have to change this, I have to change this, I have to change that. and after that the vehicle is perfect. So you will see the Elon Musk testing the starships, there are different failures, right? And after testing several models, it is there perfectly landing. So why not we take that into account that yeah, we can develop such intuitions, we can mix them with traditional physics. We have the idea that yeah, there can be catastrophic consequences. So maybe we should try to correct them, and then we should proceed. No?
I guess we need to ask deeper questions, and it's only when we ask deeper questions we find answers. Because in this world, if you go to see the word impossible, I mean it might sound cliche, and I call my podcast change I am possible, because the word itself is, if you split it up, it says the letter I am possible. The impossible word itself says so. I think we living in a world which is of endless possibility. It's just those brave scientists, engineers who need to come together and challenge the traditional way of functioning. Because at least here now I see is the physicist and the engineers are afraid to go to the no go zone, because everybody wants to create research which can go implemented and can create a business. Nobody is create business right now, so there's an economical value. Nobody is creating technology which can create a great future for us. So maybe staying there a little bit, what technology or these classified information you feel, if we can bring it to life, can completely transform the world?
So we have these technologies which are mathematically concrete and sound, but which are difficult to implement experimentally, because as I've said earlier, just because of the stringency of the natures. And there are classified technologies which are not so mathematically sound and concrete, but they somehow have taken that alternate route to explore the reality, to fool the nature, to blindfold the nature and take a turn at the side of her. Okay.
So that sounds interesting. That part sounds interesting. Where we can blindfold the nature. What are those?
So these, we have the current science which are modified, mathematical, constructed, sophisticated science, and we have that science which are not so mathematical, sophisticated. No such proper explanations are there. No such theoretical, mathematical conclusions are there, but somehow they are experimentally, quite advanced. So why not implement this too? Then we can have that mathematical sophisticacy, and we can have that thing which will blindfold the nature and take our route around her. So maybe if we can just amalgamate the two, somehow we can develop something.
I'm going to digress a bit, because what are your views on the Nick Bostrom's postulation that we live in a simulated universe, and there are it's not just Nick Bostrom. There are some there's some top physicist who says that, like Neil deGrasse Tyson, Elon Musk, Joshua Bach, Donald Hoffman, they all claim that the entire universe could be a simulation. Plus there is this something called as Mandela's effect, because and to the listeners, I mean, if you do not know much about Mandela effect, do Google it, because I think YouTube, there's so much videos out there for Mandela's effect. Just to give you one what is Mandela effect? Possibly, maybe I'll define what Mandela effect. Mandela effect is basically, there are these glitches which has happened in the universe, and to which a certain section of people believe that event which happened in the past was like this, but there's a certain section of people who disbelieve that. So for example, there was this movie called Saving Private Ryan, where Tom Hanks, he's got this scene where he's sitting in the garden, and he's talking to a nurse, and he says, life is like a box of chocolate, you never know what you're gonna get till, but there's something like that. That's the line. I can't remember the correct line, and that line, that the word, a middle word has changed, and that there's many other situations like that. So would you like to explain or talk a little bit about the Mandela effect, and the simulated universe theory?
The Mandela effect actually developed regarding a false notion of the humans regarding the death of Nelson Mandela. And it was developed by a paranormal researcher, Fiona Bloom, if you can see. So, see, there are two aspects of Mandela effects. Researchers have segregated Mandela effect, the conclusions of Mandela effect in two parts. The first part is it's a totally wax and conspiracy theory. The second part is it is some sort of a confabulation or false memory happening in our brain. Okay. So if you see that there are certain scientists who have developed the notion like we are somehow like when we are playing a computer game, we are programming that game, and all those 3D objects, they are getting displayed into a 2D perspective on the screen, right? So why not some intelligent civilizations, they have somehow achieved to simulate the whole universe, the reality, and we are just playing, we are just, that there is a notion like free will doesn't exist.
Exactly.
So who is controlling the free will? Like I can say that I will go to the gym tomorrow, but who knows that no, I can say that I will not go to the gym tomorrow, but somehow certain things happens that I am forced to go to the gym, and then I met an accident. So there's the free will exists or doesn't exist, we don't know. But what we know is that it can be possible because those super intelligent beings, if past, present, and future, as I have said, they are exist simultaneously. So at the same time I was being born, now I am sitting at the past, I am sitting here in the present, I am getting died or something like that in the future. So at that time, say a more forward increment into the future, you will see that if past, present, and future simultaneously happening on a circle, so maybe at the future, those advanced civilizations develop some sort of a tech, a hi-fi tech, and they are able to simulate the whole nature of the reality into a simulation. And we are somehow, they are portraying as a computer graphics or a game into their screen, which is a very supercomputer screen. Yes, we are there. So how can you observe the fact that we are being simulated? There are certain things, like if you see, there are glitches in the glitches. So what are the glitches? Like whenever we are playing something on a computer, we will see that our computer sometimes clutters, sometimes it hangs. So these are disturbing the games. So those who are there in the game, they are in the screen of the computer, they are experiencing that glitches. Why? Because of our problems, software problems. Like we are there, we have developed the computer and some glitches occurs in our computer, and that's why they are experiencing that.
Exactly.
If at their computers, like that super intelligent, hyper intelligent means computers, some glitches occurs, and that's why we're perceiving these conflations, false memories, deja vu, some sort of interlinking things, like maybe somehow the portal is opened, somehow two realities merge, two timelines merge, alternate timelines merge, somehow we are thinking some sort of things, but it's something like beyond the comprehension of our intelligence understanding. So what we can see is that perhaps there are some, if you see that there are some constants of the nature, like the Newton's gravitational constant, the strong, weak nuclear force. No, we are not. I'm not even. There's the speed of the light and something like this. If you see about the articles, blog post paper, you will see that several scientists claim that the speed of the light is somehow altering, somehow changing a little fraction, but they're not sure. So these alterations in the nature constant, see, little alterations will destroy our universe. Speaking frankly, the four fundamental forces are there: strong nuclear force, weak nuclear force, electromagnetic force, gravitational force. A little alteration will destroy everything. It will collapse the universe. But still, somehow scientists are claiming that some alterations are going on in the speed of the light and something like that. So these can give us a hint, like maybe just computers are cluttering, getting hanged. So, and that's why we are developing these sort of things. And another thing is that maybe sometimes your computers are hanging a little thing, and then we are developing that sort of glitches, and then suddenly they are rectifying it. And then you're okay, no, it's a false, it's a configuration, no, we are not sure about it, we don't know. And again, we are seeing some glitches, and again, it just got vanished. We're not sure. But if we think that the bread slice concept of the time, like if you take a pound, if you take a chunk of bread, and so if you put a slice in the past, you can also put a slice in the future. You can also put a slice in the present.
So
These slices are
everything exists. Everything exists. I mean, if there's the slice of bread, everything exists, and we can go back to the past or go to the present because
maybe we can't go back to the past because it will open some sort of really nasty paradoxes, like say the grandfather or something. But maybe super intelligent beings, they are not going to the past. They are not going to the past, but they have somehow taken some alternate route or somehow like this to explore the past. We don't know. We can't imagine what they are doing. Maybe they are doing something. We're not sure whether they exist or not, whether the blade size theory exists or not. But there are probabilities. In quantum mechanics, everything is a probability, right?
Right.
It will happen, it will not happen. It is existing in this world, it is existing in that world. It is happening, it is not happening. The Schrodinger cat is living. It is dead, half dead, half living, all sorts of things. Huh?
So exactly. So the world has got so much mysteries. The double slit experiment, itself says that the matter, exists only if the fundamental source code of life, the atoms exist only if they're the conscious observer which is looking, and that's the
anthropic principle. Anthropic principle. The universe makes sense to us because universe makes sense to us as we are capable of observing the universe. To a fish, universe doesn't exist.
Right, and exactly, and that there's the Hugh Everett interpretation, which says that every possibilities exist, and that's the reason we go into the multiverse. So maybe I would like you to talk a little bit about the multiverse, but before I get into that, maybe I'll unpack a little bit about whatever you said. The Mandela Effect. There is something which is like really which caught me was either the Saving Private Ryan and that. And the Snow White story, because for the longest time I remembered that, when the Snow White stands in front of the mirror, she said, "Mirror, mirror on the wall." But right now, no matter where you look, how you look, you'll never find that Snow White ever said, "Mirror, mirror on the wall." She's saying, "Magic mirror on the wall." So like that, there are so many other instances you will find if you dig deep about Mandela Effect, that there has been a change, a glitch in a universe, and there are these different what you thought was that it happened like that, and you will be surprised to find that it's not. It's completely changed. Then you mentioned about free will. There is an experiment done called Libet experiment, which kind of pushes us to question whether free will exists, because before they've done experiments and you realize that before the individual makes a decision, there is something else which is pushing the individual to take that decision. So it's so deep, but it's only, I think, there are some people who say that this is why do we even need to get into this, because it's stupid, why do you want to? But I think until we don't dig deeper, we'll never know. And the only reason humanity exists, or we have matured as a civilization, is because we have dared to ask questions. And I think there is more need for us to dare and ask more deeper questions. And it's only when we dare that we will find answers which is way beyond. My last question to you, that what I just kind of multiverse. What is it? And maybe you could also end it with India, because what are the technologies that you think will really work? There's quantum computing, there's artificial intelligence. So do share your insights on multiverse, and what are the technologies which India needs to develop today?
Look, the multiple universe is something like a concept, like there's some sort of bubbly verse. So like if you see a bathtub, there are soap bubbles are floating in the water. So there is a huge void, and there are the universes floating side by side, and everything is there. Some are there in a proper vacuum, some are not there. We have seen the limits, extreme limits, and so there are multiple opportunities. There are existence of multiverse. We are not sure how to perceive them, because we really don't know whether we live on the surface of the universe or inside the universe, because we haven't because the universe haven't opened up to us. because there are the current diameter of the universe, I think 96 billion light years or something, and beyond it, there are still unobservable parts. If you go 50 or if you go to Einstein's time, then the universe was not that much expanded as it is now. And maybe if you go 100 years later, then the universe will be more expanded. Maybe there is a huge, vast areas of universe greater than the observable universe. They are lying hidden in the unobserved universe. Lights are coming, but they haven't reached us yet. So that. Maybe we should never able to, we don't know the vastness of the universe. Maybe we should never able to perceive the vastness of the universe. But what we can do is that we should take as the alternative routes. Like, why don't we see some things like the wormhole concept is, of course, like it can take you from one galaxy to a galaxy, the other galaxy. See, the black hole concept is there. The black hole is there. Somehow the black hole might connect one universe to another universe.
Yeah, maybe the white hole, the black hole in the white hole, it's giving birth to the Big Bang. It was possibly the outcome of the black hole into a white hole.
Yeah, so that if you see the Ramanujan's theorem, which is saying that that there are two sides of infinity. Right? One is infinite simmer, which is getting smaller and smaller and smaller, and which is infinity, which is getting higher and higher and higher. As we know that infinity diverges, like very nasty divergences occur, it is getting expanded. But if you see the Ramanujan's infinite theorem, you will see that when he has developed this notion further, the Riemann zeta also incorporated this, like 1 plus 2 plus 3 plus 4 plus 6 plus 7 plus infinity, the result will be minus 1 by 12. So at some point of time, infinity itself converges.
Wow. So all of these, it's so difficult to wrap your head around. But, if we take the time and effort, we will be asking deeper questions. I need to have more conversations with you. I'm sure we're limited by time because, but really appreciate you taking time and helping me and my audience go through a journey of what could be the possibilities if we dare to ask brave questions. I really appreciate you taking time. You're saying something. Sorry, you're saying something.
Yes. So as I said that the infinity converges, so there can be some limits. Like infinity is repeating. Like you have seen that there is a concept Aleph developed by Cantor. So there is something like he kind of measured infinity. Like there is Aleph naught, there is Aleph1, Aleph2, infinity, small infinity, greater than that, defined parameterized infinity. So see, if something converges, what does that mean? Perhaps it has gone through the extreme limit and then it has started to converge. So maybe the intuition can be this, like it has gone through extreme possibilities of the multiverse. And then when it is converging, then it is a repeating of the previous possibilities. So there are theories which said that in some more distant universes, you and me at the same time we are sitting and doing this type of thing.
Exactly.
All these collapses and this probability will remain. And so we are doing these things, and different infinity also we are doing these things, and we are also doing these things. These are the things.
Lovely. So interesting. I'm so excited. But you know what? I will need to have another conversation with you again, because we need to dig deeper. We need brave individuals such as yourself who are not afraid to question who are we, why are we here, and what are the limitations that nature has set. Can we breach that? And that's such a fundamental question. And if we go and someday understand string theory, and I think we'll be able to travel, be intergalactic citizens. We could possibly be what John Sweets mentioned, like a transcension hypothesis, where we can get into the atoms It's such an exciting space. Thank you for making my day and sharing your insights. I wish you the very best. Keep on doing what you're doing, because we need people like you who are asking these deep questions. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye bye. Thank you. Thank you, Deep. Really appreciate this.